welcome back to the second part of this video series. We'll continue with the chapter electrolysis. Now we'll see in this video, first we'll see about the mechanism of electrolysis, how the process of electrolysis happens. In this one, first we have to see Arrhenius concepts. That is Svante Arrhenius, a famous chemist around 1800s. He gave up some concepts or postulates we call for explaining how the electrolysis process happening. There are four important postulates. They're quite intuitive. We'll go one by one. The electrolyte, an electrolyte, it dissolves in water. It's a basic concept. You take an electrolyte, dissolve it in water, it forms cations and anions. This one we have already seen. For example, if I take NaCl, put it into water, it will form Na+. It is cation and forms Cl- anions. Due to the formation of these ions, the electricity or electric current will flow through it. Second concept is degree of dissociation. What is degree of dissociation? When I add NaCl or any electrolyte to water, to what extent it is dissociated? Or in other words, when I add the electrolyte, as we have already seen, the bonds will be broken and it will be dissociated. That is what is called dissociation. So to what extent the bonds are broken, or to what extent the ions are formed, which is explained by the concept degree of dissociation. This is nothing but extent to which electrolyte is dissociated or broken up. And the third one is the ions will carry the electric charge, and due to the presence of ions, the electricity is transferred in the solution. Okay, so the number of ions present or the concentration of ions present is the one which determines the passage of or the transfer of electricity. Or in other terms, if I take electricity or current, which is proportional to the concentration of ions, I can just put it like this in a rough way. The current is proportional to the concentration of ions or the amount of ions present. And the fourth postulate explains, as we have seen, we will have cations and anions. The number of cations or positive charge is equals to the number of anions or the negative charge. So in a nutshell, the four postulates explain. First, we'll explain about dissociation or how an electrolyte forms cation and anion. Second one explains to what extent that is formed, that is degree of dissociation. Third postulate will explain about electric charge and the transfer of electric charge and how it is dependent on the amount of ions present. And the fourth postulate explain about number of positive and negative ions which are equal in number in a solution. Now coming to the characteristics of electrolysis. What are the characteristics of an electrolysis process? The first important characteristic of this particular process is the passage of electricity. The electricity will be passed through these particular ions, and in that case the cations, we have seen this already, the cations will move towards cathode and anions will move towards anode, as it is given here. And the second one is preferential discharge. This is quite important concept. What is preferential discharge? They are given here, preferential discharge. For example, if we have two cations, see we have seen NaCl alone or KCl alone, but we have together NaCl and KCl. Okay, now there is a competition between Na plus and K plus. Now among these two cations, or if I take two anions like Cl minus and bromine minus, among these two, which one will be moving towards the, see this is a cation and should move to cathode, which one will be preferentially moved towards cathode and will be discharged, or we will preferentially move towards cathode and gains the electron. This depends on the position in the electrochemical series, and we will see about the electrochemical series in the upcoming sections. Okay, hold this one for here. We'll explain the electrochemical series. When we explaining that, we'll explain this particular concept. And number of, it is same thing. Electrons will be gained at anode. Anode gains the electron, because anode, as we have seen, is a positive electrode and it gains the electron from anion. So the number of electrons gained by anode is equals to the number of electrons donated by the cathode. It is self-explanatory. The product of electrolysis are formed at anode and cathode. That is, when the anion moves towards anode, a product is formed. Cation moves towards cathode, another product is formed. And what is that? For example, if you have hydrogen, H plus ion, or any cation will move to cathode and will become hydrogen gas liberated, or metals will be deposited, which we will see in the further with examples in the case of PbBr2 or lead bromide or hydrogen evolution. And the non-metals will be moving towards non-metals will be moving towards anode, that is the negative ions will be moving towards anode and they will be discharged there, and we call them electronegative because they are moving towards, they are negative in charge, they're moving towards anode, and they are called as electronegative elements. Now the coming into the two concepts we have to remember: electrolytic dissociation and ionization. Both are breaking up of bonds and forming the ions. Both are in that way same, but there are slight differences. For example, in electrolytic dissociation, it happens in electrovalent or ionic compounds, and ionization happens in covalent compounds. See, in ionization, the charged ions are formed between the charged ions are formed in the molecules which are not in ionic state. But in electrolytic dissociation or electrolytic dissociation, the separation of ions occurs where the molecule is already in the ionic state. For example, PbBr2 is in ionic state, HCl is in covalent state, it forms H plus Cl minus, it is ionization, and electrolytic dissociation is the PbBr2 forming Pb2 plus and Br minus. And coming into the electrolytic dissociation, we have seen it happens in ionic compounds. Electrolytic dissociation happens in ionic compounds. And we have also seen the dissociation can happen in two forms, either when you add to water or in a solution form, or when it is heated. It is in the molten or fused form. For example, when you take a compound NaCl, first let's see in the molten. It's a simple thing. When you take NaCl, there are Na plus and Cl minus ion which are closely bound due to electrostatic, strong electrostatic attraction. This is we have seen in the in the chapter where we are in the chapter bonding, where we have discussed about ionic bond. They are Na plus Cl minus ions are held strong together by electrostatic attraction. When we taking into fused state or molten state, we supply heat. When it is heated, when it is taken into its melting point, the Na plus and Cl will be separated. The bond will be broken and Na plus and Cl minus will be separated. So we will get ions, and these ions will move towards their respective electrode. Now just take a minute and think where Na plus moves, where Cl minus. Yes, Na plus moves to cathode, Cl minus moves to anode, and this will help to conduct electricity. There is another option, that is in the aqueous solution. You can either heat NaCl or add it into water. You know, pure water is not good conductor of electricity. It's a weak electrolyte. But when you added NaCl, what happens? We know water molecule is a polar solvent. Water is a polar solvent and the molecule is polar in nature. That is, oxygen has a lone pair of electron, and also being higher in electronegativity, it attracts paired electron, this paired electron towards itself. Can you see this arrow? It's attracting this lone pair towards itself. Hence, it attains a delta minus charge, which is also delta minus charge, which is also, we can call it a partial negative charge. Similarly, the hydrogens attain partial positive charge. And we know in NaCl, we have Na plus Cl minus ions held together by strong ionic interaction or electrostatic interaction. But when you add it to water, the oxygen atom of the water molecule has a partial negative. It surrounds the sodium plus. Similarly, the hydrogen atom that is partially positive surrounds chlorine atom, and they starts pulling it. Here Na, here Cl, and it is surrounded by oxygen atoms of the water molecule. Okay, and here it will be, here we have chlorine, it is surrounded by hydrogen atoms. Don't think these hydrogen and oxygen may not be from the same molecule. It may go like this. Okay, here there is a hydrogen and here there is hydrogen. Like different oxygen water molecule can come here, and you can see here the oxygen make here and here another hydrogen. I hope this is clear. Once they start pulling Na plus one side, Cl minus other side, the bond gets broken and you have free ions which move to the respective electrode and conduct electricity. I hope this is clear how electrolytic dissociation happens in an ionic compound. Now exactly same thing happens in ionization, where it is in the covalent form. Like in the case of NaCl, we had clear plus and minus charges, but in case of HCl, this is, I think you knows the structure of HCl. This is HCl. Similar to the water, chlorine has a higher electronegativity. Take a moment and think, what is electronegativity? Electronegativity is nothing but the power of an atom to pull the bonded electron pair towards itself, which is electronegativity. So chlorine has higher electronegativity than hydrogen. So this bonded electron pair move towards chlorine, and hence chlorine will be partially negative, hydrogen will be partially positive. When I add HCl to water, the oxygen part, we have seen this already, which is partially negative, surrounds which part? Yes, it surrounds hydrogen part, H delta plus, it surrounds. H delta plus means partially positive. So this oxygen part surrounds the hydrogen part, and this hydrogen will surround this particular oxygen. Okay, the oxygen of water surrounds the hydrogen, which is delta positive of the HCl, and the chlorine is surrounded by the hydrogen of water, which is partially positive. I think you can see here the negative charges attract, hence this particular polarity is formed, and again similar in the case of NaCl, the HCl will be pulled apart and you will get H plus and Cl minus ion. And again we can see this H plus may react with water molecule and forms an ion called hydronium ion, which we will further discuss in the future section. I hope the concept about electrolytic dissociation in both fused state and solution state as well as ionization is clear to you. Now let's move to metal and electrolyte difference. There are very simple differences. Metal also conduct electricity, electrolyte also conduct electricity, but the major difference, in metal conductivity happens because of electrons, and ions conductivity happens because of ions. Electrolyte conductivity happens because of ions. And in metal, for example, you take a copper wire, there is no decomposition while passing current, because if there was decomposition, we would have not have proper wires in our houses, right? So there is no decomposition of the parent metal happens in a metal, but in electrolyte, the decomposition is the key for formation of electrolytic conduction. And metals are good conductor of electricities, but electrolytes are the good conductor of metals are good conductor of electricity in solid state. A copper wire, for example, is a solid, but electrolytes are good conductors only in fused or molten or in the solution state. They are not good conductor in solid state. I think this is quite clear to you. And during metallic conduction, there is no transfer of matter, it's just transfer of electrons. But in ionic conductivity or electrolytic conductivity, the movement happens by ions. So there is a formation, or there is a formation of matter, or there is formation of new products, which we will see in the example when we take the example of copper sulfate decomposition or lead bromide decomposition. Okay, here a simple example: copper metal is a metal conductor and copper sulfate is an electrolyte. This is just an example of a voltmeter. Here they have given. Here this is the one cathode. This is they have given as an anode. This is a cathode. What is an anode? Anode is a negative electrode. Anode is a positive electrode, cathode is a negative electrode, and you have an electrolytic solution. Here we have taken water, we'll pass the electricity, and we will start to decompose this particular electrolyte solution. Cations will move towards here, cathode, and anions will move towards this particular part, anode. I think this whole thing is explained in this particular image. I think it's quite clear. You can go through this particular image. Now we will see what is strong, weak, and non-electrolytes in case of acid base in comparison with acids, bases, and salts. Okay, the acids, bases, and salts can be further divided into either strong electrolyte or weak electrolyte. For example, you take acids. Which acid undergo complete decomposition? We know the definition of strong electrolyte. A strong electrolyte is the one which undergoes complete decomposition and forms most of it as ions. In this case, an acid, for example, mineral acid, are generally strong electrolytes like HCl. The complete dissociation happens into H plus Cl minus. Same way, nitric acid or sulfuric acid. It's a simple explanation, like all the strong acids are strong electrolytes. Same goes for bases and salts. You can see weak electrolyte, acetic. These organic acids. Acids form acetic acid, formic acid, carbonic. We will discuss about the strong and weak acids in the acid base chapter much more thoroughly. Here, just keep in mind Some examples: even bases have strong and weak electrolytes, and in salts also there are strong and weak electrolytes, and there is a direct correlation between strength of an acid and base and it being strong and weak electrolyte. What does that mean? A strong acid or a strong base will generally be strong electrolyte because it undergoes complete decomposition. But when you take weak acid or a weak base, it is weak electrolyte because it doesn't undergo complete decomposition. It has both molecules and ions. General example you can see for weak electrolyte or weak acid electrolyte: organic acids like acetic, formic acid, and weak electrolyte bases. You have calcium hydroxide, magnesium hydroxide. I think it is clear till now about the few concepts of mechanism of electrolysis and the concept of dissociation and ionization, and also strong and weak electrolyte in terms of acid, bases, and salts. In the next class, we'll see about electrochemical series, and further we will see some of the examples for the electrochemical decomposition. That is, we see the example of lead bromide, we'll see the example of water, and we'll also see the example of copper sulfate. We're using different electrodes. I hope it is clear to you till now. We shall see in the next class. Thank you.